Hi guys, as a part of chapter 9, some applications of trigonometry, we were looking at examples from our daily lives. Now here's another interesting one. It reads, two boys, Chandler and Joey, are flying kites standing on either side of a street. At a point of time when the strings of the two kites are in contact with each other, the string of Joey's kite forms an angle of 60 degrees and the string of Chandler's kite forms an angle of 45 degrees with the horizontal. It's given that both the strings are perfectly taut and the boys are standing 100 feet apart. If both the boys are 5 feet tall, we have to find out the height of the point of contact of these two strings from the ground. Now the first step is to draw the figure. So let's start with the street. Let's say this is the street and we have two boys, Chandler and Joey, standing on either side of it. So this is boy 1, this is the other boy. Now let's say this is Chandler and we'll call him C, we'll call this point C, and this is Joey, so we'll call this point J. So if this is the horizontal line, Chandler's kite is at an angle of 45 degrees. So if this angle is 45 degrees, this blue line is the string of Chandler's kite. And we know Joey's kite makes an angle of 60 degrees. So let's say this is the string of Joey's kite, the green one. It forms a larger angle that is of 60 degrees. So if this angle is 60 degrees and this one is Joey's kite, we know that the strings are taut, so they are in a straight line, a perfect straight line. We are given that the boys are standing 100 feet apart, so this distance is 100 feet. We know heights of these two boys is 5 feet, so this distance is 5 feet. So is this distance. Let me name the points on the ground where their feet are. So Chandler, this point let it be B. For Joey, the point on the ground be T. Let this point, the point of intersection, whose height we have to find out, let that be point I. And the point on ground right below the point of intersection, so that would be this point. The point on the road, let that be point R, and let this point be called S. So this is the figure. If we observe carefully, this angle is 90 degrees, so is this angle. In this figure, we are supposed to find out the height of point of contact of the two strings from the ground. So if this black one is the road, then we have to find out the length of Ri. We are also given the length of BT is equal to 100 feet. Now we know BT is equal to CJ, so CJ is also equal to 100 feet. And the height of the boys, that is BC, is equal to JT, that is equal to 5 feet. Angle ICS is equal to 45 degrees and angle IJS is equal to 60 degrees. So all this is given to us and we are supposed to find out the measure of Ri. Now here we have two right angled triangles. So in triangle CSI, we have angle S as 90 degrees and we know angle C is 45 degrees. So we'll take all ratios for angle C. Now here we have to find out this length. If we know the measure of SI, we will be able to find out the measure of RI because we know SR would be equal to the height of the boys, that is 5 feet. So in this triangle CSI, if we take tan of angle C, that is tan of 45 degrees, that would be equal to perpendicular or the opposite side, that is SI, over the adjacent side, that is CS. And we know tan 45 is nothing but 1. So we will have SI equal to CS. Let this be equation 1. Now let's consider the other right angle triangle, that is triangle JSI. Here again angle S is 90 degrees and we know angle J is equal to 60 degrees. We'll again take tan. So we'll have tan of angle J, that is tan of 60 degrees, equal to the opposite side, that is SI, over the adjacent side, that is SJ. And we know tan of 60 degrees is root 3. So from here we would have SI is equal to root 3 times SJ. This is equation 2. Now we have these two equations which relate SI to CS and SJ. Now, do we have any other relationship where we can find out the values of CS, SJ or SI? Let's look at what was given to us. So, these things were given to us. Here, we see that CJ is equal to 100 feet. And we also know that CJ is this distance, which can also be written as CS plus SJ. So we have a relationship which says CS plus SJ is equal to 100 feet. So can we use that along with equations 1 and 2 and find out the value of SI? Let's see. So we have a third relationship which says CS plus SJ equal to 100. Now if we put the values of CS and SJ from equations 1 and 2, we would have CS is equal to SI plus, here we see SJ would be equal to SI by root 3. So if I put that value, I would have SI by root 3 is equal to 100. Now this gives me SI into 1 plus 1 by root 3 is equal to 100. Or if I solve this further, I would have SI is equal to 100 into root 3 over root 3 plus 1. Now if I just replace root 3 by 1.732, I will get SI is equal to 100 feet into 1.73 divided by 1.73 plus 1, or I can write it as 2.73. And we can easily solve it, and we would have SI is equal to 63.37 feet. Now this is the measure of SI. Now were we supposed to find out SI? No, we had to find out RI. So we know SI, this length, is equal to 63.37 feet. And RI is nothing but SI plus RS. So RI is equal to SI plus RS. And we know SI as 63.37 feet. And we know RS as 5 feet. So this would be 63.37 feet plus 5 feet. So that would be equal to 68.37 feet. So that's our answer. So RI is equal to 68.37 feet. That's the height of the point of intersection from the ground level. By now, I'm sure you have become great at solving trigonometric problems. It's not very difficult. We just have to transform the long given problems into a figure and then just find out what the distances or heights would be. It's pretty simple, isn't it? I'll see you in the next video then. Bye.